super excited that we're talking to Paul Lipkin from ChargePoint. And if you don't know who ChargePoint is, they lead the entire world basically in electric vehicle charging systems. And we're really fortunate to have Paul, who's brought through a startup a really amazing innovation in smart charging. And we're really proud to be a partner of yours on a project we've been working on in Santa Clara Valley. So Paul, thank you so much for being here.
Sure. Thanks, Doug.
Yeah, so why don't we start here? Tell us a little bit about yourself and how you came upon smart charging as a big adventure, and maybe tell us just a little bit about what smart charging is from your perspective.
Sure. So let me answer that in reverse order. What is smart charging? I'll tell you how we got into it. So smart charging is not dumb charging. Dumb charging or uncontrolled charging is you plug your vehicle in and it just charges. You can't slow it down, you can't control it. So that's sort of the default method of charging. Smart charging says there's some things I want to do to shift the charging or to react to things happening in the environment to be able to move that load, that charging load, to a better point in time. So smart charging is basically taking factors like other load on the circuit, solar energy being generated, state of charge of a stationary battery, of course the tariffs, the fees the utilities are going to charge you, taking all that into account and then optimizing how you charge your vehicle or vehicles. So how we got here is I worked a company that was doing some demand response energy work, and we were asked by Lawrence Berkeley National Lab to help out in a project at the Los Angeles Air Force Base. And that was super innovative. It was vehicle to grid. We actually had 30 vehicles participating in a market and contributing to the regulation services market at Cal ISO.
Right, and these are the early days. So this is what, 2008?
So this is 2012 probably.
Oh, okay.
When we started that project. And then we left that project, went to work with Prospect Silicon Valley on a Santa Clara Valley Transit Authority project. And that was to look at electrification of buses. I don't know if you know this, but over the next 10 years, all the buses in California begin to electrify. No diesel bus to be sold after 2030. And so a big project, very important. This is the first 5 of what's going to be hundreds of buses going electric at Santa Clara Valley. Right. So we built a system with a number of other partners to optimize the charging of this bus fleet, and really planning on not how to optimize 5 buses, but 50 and even 500 beyond that originally in our plans. And so that was successfully rolled out about a year ago. But actually almost 2 years ago before that, 2 years ago from now, ChargePoint decided to add fleet to their portfolio of charging products. And we were a perfect match having fleet software to work with ChargePoint. So now our team is fully part of ChargePoint.
Right, so you started the project with us as a startup, KeySensum.
Yes, correct.
And then partly through the project, partnering with ChargePoint on the project, you became
That's right. You lost a partner in the deal. You had one less partner.
But I love it. I love it. I think it's fantastic. So maybe educate us a little bit. You know, charging a fleet of cars has a set of challenges. But then when you start to charge a bus, and you're charging a bus that's actually running transit service, what kind of challenges do you run into there? And maybe give some folks a picture of the difference in scale between a car battery and a bus battery.
Yeah. So in the original LA Air Force Base project, we were doing Leafs, and they were, I believe, 40 kilowatt hours, excuse me.
Mm-hmm.
And so you could charge a 40 kilowatt hour leaf in an hour and a half, maybe 2 hours at a reasonable rate. You also could easily just use a 7 kilowatt AC charger and charge it over a matter of 5 or 6 hours. I think about a Tesla, 100 kilowatt hour battery. Now at AC, even a level 2 AC, which means 7 kilowatts, like your dryer plug, basically, that's going to take you to fill that battery up 10 to 12 hours at least. That's 100 kilowatt hours battery. These transit buses have 400 kilowatt hour batteries, so 4 times the biggest Tesla battery. And so there, you can't do AC. You really have to look at fast DC charging. And you kind of want to go at least 50 kilowatts would be the minimum, I would say. And even at 50 kilowatts, it's going to take you 6 or 7 hours to charge that vehicle. So the challenges are, if I have 50 buses, each at 50 kilowatts, that's 2.5 megawatts. That's more than your typical parking lot has available. And so you have to, plan for what's your rollout size so you can get your new utility service in. And then you also have to make sure that you don't charge a whole bunch when the buses first get back, then have it be idle late at night. You want to flatten that load. So you want to make sure that you don't overbuy your infrastructure, you don't overpay for demand charges, and you manage the buses charging so that you basically have the same power level throughout the whole evening. But at the back end, you want to make sure you have an hour or two available, a buffer, just in case something happens.
Yeah, and so, VTA being one transit agency in California amongst a whole lot of them across the state,
Right.
They currently have a fleet of 550 buses. So if you're electrifying 550 buses and operating the lion's share of them on a daily basis, and you're looking at needing to, you start talking about loads that are on the kind of the order of powering small neighborhoods, right?
Right. Right. No. Yes. You may not even have that much power available at the distribution centers. You have to really think long and hard about how can the utility support you for that massive load. Yeah. So 500 buses at 550 kilowatts. That's like 250 megawatts of power. So you're going to have to find a way to spread that out. And use solar and maybe use batteries and do a lot of the strategies to soften that load.
Right. So we were really excited to be able to work with you on this project and to work with the Santa Clara Valley Transportation Authority and NREL and other partners. It's been an exciting go. It's also been a huge challenge because of the fact that we're piloting these things in an operating transit agency. I think I would ask, when you think about the future, when you think about what you've learned and how ChargePoint has kind of lifted up your idea, in terms of how this works for fleets of cars and what you've learned about fleets of buses and where that's headed. We're looking at a massive push of electrifying a lot of otherwise, carbon heavy power sources, right? And I guess my question becomes, where do you see the biggest kind of overall decarbonization impact from smart charging? Do you think that it's going to be in the automotive sector? Is it going to be in the consumer sector? Is it going to be in the areas like transit and other institutions? Where do you think the biggest change is going to come?
I mean, it's going to be phased. So I think that over the next 20, 30 years, you're going to have the consumer vehicles go from its current 1% to 80, 90% eventually over maybe 50 years. So that's going to be a nice steady growth. I think you're going to have some big bursts of electrification with delivery. A lot of package delivery and mail delivery, and that's just a natural because they're relatively short routes, lots of stops, really great opportunity for electrification. And then transit's a nice, steady, especially in California, 10 to 15-year rollout. And really, the thing that's great about electric vehicle charging is it's movable. And so you can move it. So you see as wind shifts, as wind grows and you have some wind power, you can go ahead and shift that load into that. If you can find ways to charge with solar, you can move the charging in the daytime. A lot of workplace charging is during the daytime. And so it's not just running air conditioning where if you turn it off, people get hot. You usually have a lot of hours to charge these vehicles. If you charge them fast, you can move that around. And so to me, that's our big win, is that we have the ability to shape the charging load to match the supply load. And we'll get to use all the renewables, and that's great for decarbonization.
Right. So statewide, being able to balance demands on the grid, which are obviously going to be a much bigger deal as the entire kind of vehicle profile becomes more and more electric. So will there be, just speaking of product and thinking about smart charging being an aspect of a charging system, we've been talking a lot about fleets. Will there be a home version of smart charging?
So absolutely, there already is a fair amount of smart charging in the home chargers, both ChargePoint and others, as well as the vehicle driving that charging. And so, what you typically have is many utilities have a time of use rate where it's cheaper to charge after 11 p.m. or midnight. And a lot of the cars and the chargers can let you just dial in. Go ahead and plug in when you get home, but wake up at 11 o'clock and actually do the charging. Or midnight. And that typically works well for home charging. Everybody who's got an electric vehicle, 99% plus, also has Wi-Fi. And so to have a connected charger and have aggregation certainly makes sense. And most home chargers today, the modern ones, will be connected and will be network driven. So absolutely, home charging is a big piece of it.
Right. So, since you know a little bit about charging, Paul, maybe just a little bit.
A little bit.
Why don't we just kind of talk a little bit about kind of things around charging? Two questions I'd have for you. One, that the work you've been doing has been around actually making charging smart. Any comments on whether inductive charging is really is positioned for the future? And second of all, what's your thought on ways to automate charging, given that we do think there's going to be more and more autonomy in our vehicle universe?
So that's a great question, and what ChargePoint's doing, what we're doing at ChargePoint, is we're often separating the conversion of AC power to DC power, and DC is how you really want to charge these vehicles, because DC and AC inverters can be big, and you don't want to put that in the vehicle, you want to put that on the ground.
Right.
And so we've now separated, so we have this sort of power supply, and then we have dispensers going out to the vehicles. But those could be, rather than physical hoses that you grab and plug in, they could be overhead gantry. So a lot of the bus projects are looking at gantry, where they drive up and then you come down with a metal connector and actually don't have to physically plug it in. We're looking at some robot arms. We actually are doing some experiments. May not be ours, but we certainly would interface to them that would come out for autonomous cars and plug in. There certainly is a inductive charging is possible, where you actually have the charging plate a few inches from the bottom of the vehicle. That's certainly possible, and there are certain applications where that might lend itself to that. If we ever open up airports again, airport vans would be a good application for that, where all the rent-a-car pickup buses and vans could go to the curbside, and they could be getting mini charges as they're parked. And so I think that all those things are gonna happen over time. And the smart charging, though, could be independent of that, because it's basically driving the DC current to whatever kind of connector you have, whether it's a robot arm or overhead gantry or inductive. You still want to manage that charging load just based on when it's most efficient to get the energy to the vehicle.
Right, whether it's a little sip or if it's a whole bunch at one time. It's about doing this the smart way. Well, this has been
exactly.
This has been really excellent. Now we do keep it to 15 minutes, otherwise we'd have to change the name. So we really do appreciate you spending time with us. This has been a great conversation. We've shared Paul's contact information, and if anybody hasn't heard of ChargePoint, there is a website. You can take a look at it. You're going to be about the last person on earth not to know, but certainly I think that Paul would welcome you getting in touch, and certainly get in touch with us. We're going to continue to do this series. We're going to take a break next week, but we're going to come back on a bi-weekly basis and keep this going. So thanks, everybody. We'll talk to you soon.